Hey guys, I was going to do a quick little semester exam practice problem. So just in case you missed yesterday, the video is out there. You can watch it, but just to kind of get you going and making sure you're understanding some things. Remember this equation here. What I would do anytime you're doing this equation is I would make sure that we treat the equation as is before we put in a negative or positive work, because it gets confusing on what might happen there. So like on your practice or your review, we added W over here and it was a positive work. If you put your positive work in here, then you still have to add W to the other side, but people can kind of get confused whenever you have that subtraction sign. I typically solve for what we want it to be and then plug in the numbers. Example, say I wanted to isolate W and I wanted to solve for W, the work done. What I would do is I would add W over here and subtract delta U over here. So you would have something along the lines of this. If I add W to both sides and subtract delta U from both sides, add W, subtract delta U, then delta U would go away, W would go away, and we would have W equals Q minus delta U. So then, if I gave you your heat, you put your heat in, and you subtract your change in internal energy, and whatever that difference then would be work. Now, if we think about this, this should make sense to us. If we had work is also equal to Q H minus QC. So whatever heat we put in should probably do some work, and then some heat's going to be let out. And so that's when we get into the efficiency of engines. So hopefully that kind of helps you through that, and just some reminders of how to do this equation. But that's my little short tidbit on the first law of thermodynamics. Remember, this equation is the first law of thermodynamics, and it's a restatement of the law of conservation of energy.